here are the defecating elks. Hope you enjoy our soils.
A Coors Light is just like the Kaiba series. I don't really know how the glaciers and the mountains in the Coors Light picture were created, but maybe they were created by glaciers, similar to the parent material that makes up the Kaiba series, streams that pushed sediment through the Great Lakes and created this island that the Kaiba series is found on. Some may say Coors Light is a very watery beer. Just like the Kaiba series receives 30 inches of precipitation on average annually. This makes it so the Kaiba series never has a deficit in plant available water. In late summer and early fall, there's a small usage period, but the Kaiba series very rarely runs low on plant available water. The Kaiba series, made up of a sandy loam, is like a Coors Light because I love to enjoy a good Coors Light while I'm sitting in some sandy loam.
This Busch Light apple is like the Tokay series of soil. So let's first look at where it was bottled, or where the Tokay soil is found. And it's found in the Central Valley of California between two mountain ranges. There's the coastal mountain ranges to the west and the Sierra Nevada mountain range to the east. Then we can look at the ingredients. So it is made out of granitic alluvium. So when the glaciers in the Sierra Nevada mountain range would recede and melt, they would dump a bunch of material down to the adjacent valley. So that's where a lot of the ingredients for the Tokay soil, or like the parent material, come from. Next, we can look at the texture. And so, yeah, the Tokay soil and this bush apple is a fine, like sandy loam texture. So there's definitely some grit from those like granitic deposits from the glaciers, but also some finer material in the loam. And the color is pretty light. So as you'd expect from a Busch Light, the color is light, and that's due to it being a very high agricultural region. So there's been a lot of plowing stuff in recent years, which has eliminated the organic dark topsoil. And also we can look at the structure. So at the top there is like subangular blocky, and then it goes to blocky and massive, and that indicates that there's likely some clays in the soil which have been leached, and that's really important for water holding capacity. And as I said, the region is very high producer of crops, mostly like grapes, and it doesn't receive that much precipitation, only winter precipitation, so it isn't a deficit much of the year. And it's really important to have those clays and finer materials so that way the water can hold, or the soil can hold more water. Cheers.
And I have here my soil, the Farmer series. This is formed by mixed loess and volcanic ash over the top of older loess. This soil is located in north central Washington, mostly found in drier regions on the plateaus, such as my hometown, Waterville, Washington. Farmer series here has 6 ingredients, 6 different layers. You have the AP layer that goes from 0 to 11 inches, the BA layer that goes from 11 to 19 inches, the 2BT1 layer that goes from 19 to 28 inches, the 2BT2 layer that goes from 28 to 40 inches, the 3BT3 layer that goes from 40 to 52 inches, and finally the 3BT4 layer that goes from 52 to 60 inches. This soil is used primarily for dry land crops such as wheat and barley. The annual water budget is mostly in the deficit, besides for 3 months out of the year. So we say cheers to the Farmer series.
And my favorite soils was on the Bear Paw soil series, which is located in north central Montana. And in this video, we're going to pretend that this Rainier beer can is all full of that Bear Paw soil. So let's get cracking on it. So the Bear Paw soil series is home to some farm ground. It has a total of 7 different layers, with the top layer being a heavy AP horizon due to the farming. In the middle, So if we were to dig to the middle of this can, you're going to find thick BT and thick BK layers. And then the parent material of the soil is going to be like a clay loam, glacial till. And the soil's in an area where there's less precipitation than the evapotranspiration, so it's always in deficit.